Welcome everyone to our video on partial neutralization. In this video, we will learn how to determine the pH of a solution when a strong acid is only partially neutralized by a strong base. Here's the problem we're going to be solving today. 25 milliliters of a 0.1 molar HCl solution is reacted with 20 milliliters of a 0.05 molar NaOH solution. We want to determine the pH of the resulting solution. Note that this is a regular acid-base neutralization reaction between a strong acid, HCl, and a strong base, NaOH. Before switching over to the whiteboard, let's go through the steps to solving these problems. First, we are going to compare the moles of hydrogen ions provided by the acid to the moles of hydroxide ions provided from the base. If they were to be equal, then it is a complete neutralization problem and the solution will be neutral. If they are not equal, we will need to determine which one is in excess and determine the excess amount. We will then take that excess amount and calculate the concentrations of hydrogen or hydroxide ions in the product solution, which will enable us to then calculate the pH. Let's now switch over to the whiteboard and solve this problem. Our first step to solving this problem is to compare the moles of hydrogen ions to the moles of hydroxide ions. We can find the moles of hydrogen ions by using this simple formula. We take the number of hydrogen ions in the formula for the acid, multiply it by the concentration of the acid, multiplied by the volume of the acid. So in this case, we have 2.5 times 10 to the negative 3 moles of hydrogen ions. Let's do the same thing for the moles of hydroxide using the concentration, volume, and formula of the base. We will have an acidic solution, we just need to find the pH. Our next step is to determine how much hydrogen ions are left over. Hydrogen and hydroxide ions react in a 1-to-1 ratio, so if we subtract the moles of hydroxide from the moles of hydrogen, we will get the excess moles of hydrogen. We find that after partial neutralization, there are 1.5 times 10 to the negative 3 moles of hydrogen ions in excess. Once again, we took the initial quantity of hydrogen ions and we subtracted the quantity of hydroxide ions because the hydroxide and hydrogen react in a 1-to-1 ratio. Now we need to find the concentration of those hydrogen ions. Note that when we found the concentration of the hydrogen ions, we had to take into the account that we mixed two solutions. So the volume that we're using is the sum of the volume of the acid and the volume of the base. Now that we know the amount concentration of the hydrogen ions, we can calculate the pH. We find the pH to be approximately 1.48, so still an acidic solution due to the excess of hydrogen ions present.